and store them in a appointed location. Server informs the terminal through TCP/IP that data is ready, and terminal downloads from the server FTP and display the data files generated by the server. And the algorithm is based on the relationship between Rx and Ro. Rx is the actual reporting interval at the reporting points. Ro is the interval specified by AIS standards. Rb is the coverage rate of station. You can see if Rx more than 1, then Rb equal 100%, or Rb equal RORX. This graph below shows the overlay of South China Sea before treatment and after treatment. And the coverage rate is indicated with different colors to show difference as follows. You can see in this graph from red to purple, from 100% to 1%. The coverage rate is easy to be influenced by individual ships in places where the number of ships is smaller. The software calculates the AI signal reception rate of all ships, which also verify the signal coverage rate of AI station in directory. Both provide references for performance assessment of AI station. The graph shows the signal reception status in April 2009 at the Pearl River estuary in the South China Sea. And this graph shows the text point sample from the previous graph. In this graph, you can see we have 3 text points, and the total AIS target of text point and the average coverage rate is different. The checks of ships in the Pearl River estuary. The statistic graph on the ship traffic flow in the Pearl River estuary. Benefits. It can be calculated the coverage rate of AI stations accurately in certain time period. It can check the utilization rate of AI signals to verify the effectiveness and the performance of AI station. It serves as basis for adjustment of AIs in the main loads and the customary loads. It can be used to verify AIs VHF signal coverage performance in directory. Performance and stability. OSANT AIS started to run in April 2008, and it runs so well so far. The terminal software has never been interrupted or crashed. It is very quick to inquire the coverage of a point area through local LAN. We saw the factor that affect statistical results is OSAN AIS will run normally, assuming that the AIS station and the network are in normal operation. The ship-bound AIS, including the antenna feeder system, working properly. The signal utilization rate in area far beyond the coverage of AI station should be analyzed and compared in different time ranges. Finally, conclusion. Based on AIS network system, OSANT AIS use extensive data for statistics, analysis, and display. Secondly, by selecting different time regions for monitoring, it serves as a useful tool to describe the link reception effect of AI stations, test the coverage of AI signals in directory, and check the working status of AI station. Finally, this system plays a very useful role in assessing the status of AI station and the network systems. Thanks for your attention.
be presented by two presenters. The first one is Marcus Sportin, research scientist of VTT Technical Research Center in Finland. He is member of the IALA Risk Management Steering Group. The second part of the paper will be presented by Rolf Zetterberg, project manager and technical advisor of the Swedish Maritime Administration. He is member of the AIS Technical Working Group of the E-Navigation Committee and will take over the chairmanship of that working group after the conference. We start with Marcus.
Thank you, Mr. Chairman, and good morning to everyone. So I will tell you about the AIS binary messages, developments in the Baltic, and progress in IMO. I will start with the AIS application-specific messages and the Baltic AIS trial project, and then Rolf will tell you about a project of application-specific messages in IMO and draw the conclusions. As you all know, the AIS is a powerful tool for ship identification and tracking, but it has some deficiencies. Some relevant information is defined in a less than optimal form, based on outdated definitions, or totally lacking. So therefore the AIS could be developed to meet better or more efficiently the needs of the users both ashore and on board. The objective of the Baltic AIS trial or AIS Baltic project was to propose changes to AIS in order to enhance the situational awareness of the officer on the watch, reduce workload on board, and improve information quality ashore. AIS is structured in 26 message types, and I will focus on types 6 and 8, binary addressed and binary broadcast messages. These are special in that sense that multiple content structures can be defined, and the structure is determined by the application identifier in the beginning of the message. The use of application-specific messages started in 2004 when IMO published 7 trial messages for a 4-year trial period. But however, the full potential offered by these messages was not fully exploited yet. So to the AIS Baltic project, it was a 3-year project from 2007 to 2009. We had partners and funding from Finland, Sweden and Estonia, and a wide range of authorities from almost all Baltic Sea countries. This was all possible because maritime safety is regarded very, very important in the area, and we have cooperative states around the coast. And it was also part of the Baltic Sea Action Plan of the Baltic Marine Environment Protection Commission, HELCOM. We tested the IMO trial messages between Helsinki VTS and dedicated vessels in the Gulf of Finland. Technically, the messages worked well. They contained relevant information, but not always in an optimal form. So to find out what to do, we had an information need survey in the Baltic Sea area. The aim was to find out what information authorities would need from AIS to carry out their duties efficiently. And it was structured in a series of workshops and followed by working groups. We had both face-to-face and internet-based meetings. And again, a wide range of participants from different kinds of authorities dealing with maritime issues. So the main result was 5 new application-specific message proposals based on identified needs. And I would like to thank the RTCM project from USA for cooperation in finalizing of these messages. So 3 messages. First, 2 improved versions of the trial messages. Dangerous cargo indication message is now, with that it's now possible to report multiple cargo types in one message, and it